Hello, welcome to the next chapter of science. We are going on to 4.12 today, which is motion, movement with energy. So we're going to be on page 201 and we're going to start reading about motion. Motion. So objects, to define motion, to analyze a system to determine net force, compare speed, velocity, and acceleration, calculate speed, velocity, and acceleration. And some vocabulary words before we start. Acceleration is the rate of change in velocity over time. Net force is the total of all the forces acting on an object. Reference point, a point against which the position of an object is measured. Speed, the rate at which an object moves. And velocity, the speed of an object in a particular direction. All forces have two components: magnitude, which is the size or strength, and direction. For instance, the force of gravity depends on the mass of an object, the objects involved. The force of gravity is greater on an elephant than it is on a house cat. That is why the elephant weighs more. When discussing gravity, direction is always down towards the center of the earth. But what about other forces? What about contact forces? When a force is applied to an object, the purpose is to create change. When a wagon is pulled, it will move. When a lump of clay is pressed, the shape will change. Sometimes, when a large object is pushed, however, it does not move. Why? The forces applied are balanced, so no change takes place. At all times, several forces are acting on an object. Consider a book on a table. Nothing appears to be happening. However, at least two forces are at work within it. Gravity is holding it down, and friction is keeping it in place. The forces are balanced, so no change is taking place. When a pushing force is applied, the book can move across the table. Pushing it produces greater force than the frictional force working against the motion. All the forces added together is called the net force. For example, if a box is pushed in one direction with 95 newtons of force, and the weight of the box pushes back with 80 newtons, and that frictional force also helps push back with 15 newtons, there is a balanced system and the net force of 0. The box does not move. But suppose two people push. Now, one is pushing with 95 newtons and the other is pushing with 80 newtons, and the box and friction are still pushing back with only 95 newtons of force. One side of the equation indicates 175 newtons, and the other shows 95 newtons. This force is unbalanced. The net force is 80, and the box moves. Motion is the result of unbalanced forces where the net force is not equal to 0. If the net force in a system is not known, how do we know something is in motion? Imagine riding in a car and traveling next to a train with the same velocity. The train appears not to be moving. To determine its motion, look for a reference point. Choose a part of the train to focus on, and then watch to see if it passes a reference point. If it does, then the train is moving. If the reference point is a stationary object against which the position of an object is measured, all motion is relative. If you think of that, if you've ever been on a train, maybe sitting, waiting at a train station, and another train passes, or another train starts moving slowly next to you, it's hard to tell, are we moving? Are they moving? And this is kind of what they're saying is find a reference point to see, is it actually moving or is it not? Is that reference point staying at the same distance to me as it was before, or is it moving farther apart? Here's an example. Suppose you look out the window and you see a garbage truck in front of your house. A few minutes later, you look out the window again. This time, the truck is 2 houses down the street. How do you know you moved if you did not see it move? Its position is compared to a reference point. In this case, the front of your house is the reference point. The garbage truck is no longer next to your house. If the position of an object is changing in relation to the reference point, it is motion. What about two people riding inside the truck? In relation to each other, they are not moving. In relation to your house, they are. For the garbage truck to move, it has to create an unbalanced force. The engine has to move the wheels with enough force to overcome the weight of the truck and the friction on the road. When the workers are collecting garbage, the truck moves slowly. They move at a slow rate of speed, which is determined by measuring the distance traveled and dividing it by the time it takes to travel the distance. Speed equals distance divided by time, like you have miles per hour. If the garbage truck travels 4 kilometers in 2 hours, the average speed can be calculated. Speed equals 4 kilometers divided by 2 hours, or 2 kilometers per hour. Average speed is the rate at which the truck moves a certain distance over a set amount of time. Instantaneous speed, on the other hand, measures speed at a given instance. For example, if it takes 30 minutes to drive through a city that is 10 kilometers across, the average speed is 20 kilometers per hour. For part of the drive, the car travels at 40 kilometers per hour, but at other times it is stopped at a traffic light. At that moment, the instantaneous speed is 0 kilometers per hour. The speed of 20 kilometers per hour is simply an average. Besides knowing the speed of an object, it is helpful to know the direction it is traveling. Velocity is the speed with direction. A school bus travels an average speed of 40 kilometers per hour. It benefits you to know that the bus is moving towards or away from the bus stop. If the bus is heading towards the bus stop, the velocity of the bus is 40 kilometers per hour towards the bus stop. Speed only gives the distance something travels over an amount of time. Velocity includes the direction of travel. So try this. Relative motion. The direction of travel is important in determining the impact of a crash. Make 2 stacks of books of equal height. Create 2 ramps facing each other using the stacks of books and boards, leaving enough space between the boards for an egg to fit. Read all the directions before starting and hypothesizing which trial will cause the least damage and which trial will cause the most damage. Trial 1. Roll 2 eggs, one in front of the other, down the same ramp at the same time. Trial 2. Set 1 egg at the bottom of the ramp and roll the other egg down the ramp into it. Trial 3. Simultaneously roll 1 egg down each ramp. Record what happened in each trial. What is the damage difference in each trial? Which trial caused the least damage? Which trial caused the most damage? How do the results compare in hypothesis? If your parents don't want you using real eggs and you'd like to try this, you could always use a plastic Easter egg. I'm sure you have a lot of those around right now. And if you want to, you could put like a marble or something in it to give it weight and see what would happen. Trying all 3 of those trials. Another instance where velocity is important includes the motion of 2 objects. If 2 cars are traveling at 40 kilometers per hour on the same road, it's important to know where they are in relation to each other. If the cars are both moving east, the passengers in the cars should enjoy the trip without incident. They can travel next to each other or one in front of the other. Relative to each other, they are not even moving. But what if one car is moving east and one is moving west? If the 2 cars are moving towards each other, they could collide. When the 2 cars are moving in opposite directions, add the speed to determine the relative speed, or in this case, the speed of collision. This head-on collision would occur at 80 kilometers per hour. If the cars are moving in opposite directions away from each other, they are moving away from each other at 80 kilometers per hour. Could 2 cars traveling in the same direction ever collide? Yes. If the first car, or the one in front, is moving at a velocity of 40 kilometers north, and the one behind is moving at a velocity of 80 kilometers per hour north, the second car could hit the first car. What would be the speed of collision? Because the cars are moving in the same direction, the velocities are subtracted. 80 kilometers per hour minus 40 kilometers per hour equals 40 kilometers per hour north. So, for instance, Or let me finish this. A crash occurs when both cars are moving in the same direction and had a smaller magnitude than when the cars are heading towards each other. So, for instance, if you are driving down the highway and someone got on going in the wrong direction and they're driving straight for you and you collide, head-on collision, the speed at which you're going and the speed at which they're going is added together. And that velocity, the speed with direction, added together is the force in which the impact creates energy-wise. And so if you're driving 60 and they're driving 40, that's 100 mile per hour collision. So it's like you're hitting something with as if you were driving 100 miles per hour and crashing into a tree. It's a lot of force. On the other hand, if you have a rear end collision, if you're driving 60 miles per hour and they're driving 40 miles per hour, or other way around, if you're driving 40 and they're driving 60 and they slam into your bumper for a rear collision, those are the speeds, the velocities are subtracted from each other. Because you're moving in the same direction, there isn't as much as that collision force of coming together because you're hitting it and it's pushing the other in front. So it's releasing some of that energy rather than hitting each other and going up. One is hitting the other and pushing it forward more. There is still an impact, but it's lesser than if you were hitting head on. If the driver of the first car looks in the rearview mirror and sees a car coming quickly, she may decide to change her speed to avoid getting hit. The rate of change in velocity is called acceleration. A change in velocity can be an increased speed, a decrease in speed, or a change in direction. The first driver was originally traveling with a velocity of 40 kilometers per hour north. She sees a car behind her getting closer and she starts accelerating. Her speed increases from 40 kilometers per hour to 50 kilometers per hour to 60 to 70 to 80 in over a 10-second period of time. The rate of acceleration can be calculated. So A, acceleration, equals velocity first, velocity, the next one, minus the second velocity, divided by TF over T1. If we look up at top, the laws of principles, speed, velocity, and acceleration. Speed is the distance of an object that an object travels divided by the time it takes to travel the distance. So, a car travels north 240 kilometers in 4 hours. So, 240 kilometers per 4 hours is 60 kilometers per hour. The car's speed is 60 kilometers per hour. Velocity is the speed with direction. The car's velocity is 60 kilometers per hour north. Acceleration measures the rate and change in velocity. An acceleration of 9.8 meters per second squares means that an object is changing its speed by 9.8 meters per second every second. To determine the acceleration of an object, use the final velocity, so F for final, not first, F for final velocity, and the initial velocity. And it's time over which the change takes place. So you're doing, what is the final velocity? So she ended at 80 kilometers per hour. So final velocity minus what she started at, 40 kilometers per hour. Suppose a skateboarder starts at the top of a hill with a velocity of 0. 3 seconds later, he is traveling down the hill at 12 meters per second. Use this equation to determine the acceleration. So you have 12 meters per second, the final, subtracted by the initial, which was 0 meters per second, and you get 12 meters per second. The time, the initial time, or the final time is 3 seconds. The initial time is 0 seconds, so it would be over 3. So 12 divided by 3 is 4 meters per second squared. The skateboarder increased his speed by 4 meters per second every second. He accelerated 4 meters per second squared down the hill. So that shows the rate of acceleration. In this formula, A is acceleration, VF is the final velocity, and VI is the initial velocity. TF is the final time, and TI is the initial time. Sometimes something is wrong with this equation above. The units used to measure time are different. In order for a statement to make sense, the units must be the same. We've gone over this in math. Acceleration is normally measured in meters per second. To calculate, convert the hours to seconds. So 1 hour times 60 minutes times 60 seconds is 3,600 seconds. So there are 3,600 seconds in an hour. So then we can solve it. 40 kilometers per 3,600 seconds divided by 10 seconds, the total time it took to accelerate. One more conversion is needed, converted kilometers to meters. So there's 1,000 meters per 9 seconds. And so you would end up with 11.11 meters per second squared. This means that the driver increased her speed by 11.11 meters per second every second. In the example, the acceleration was positive, or the change in velocity was an increase. Acceleration can also be negative, meaning the object is slowing down. If a rabbit is running at a velocity of 3 meters per second north for 20 seconds and then takes 2 seconds to stop, the rabbit's acceleration is 1.5 meters per second. So it decreases. The negative sign signifies an acceleration in the opposite direction of the original motion. The rabbit slowed down or decreased velocity at a rate of 1.5 meters per second south. Also, acceleration can simply be a change in direction. A plane can travel with a velocity of 450 kilometers per hour west and then accelerate to a velocity of 450 kilometers per hour north. Questions. Number 1, describe motion. What is the definition of motion? Number 2, how do you know whether a system has a balanced force? What are the indicators that need to be there in order for it to be balanced, meaning not moving? If one car travels 60 kilometers per hour west and another car travels 80 kilometers per hour west, what is their rate of velocity? Or what is their relative velocity? And will they collide? Number 4, if you travel 150 kilometers in 4 hours, what is your average speed? And number 5, if it takes you 9 seconds to increase velocity from 0 kilometers per hour to 40 kilometers per hour east, what is your acceleration? So use those formulas. Make sure you're converting if you need to, so you have the same units of speed, of time, and of measure, of distance. When you're done answering those questions, looking at the lab 4.12, you have velocity and acceleration. So things that you would need in order to complete this lab are several books, a board or a Hot Wheels track. If you have one of those Hot Wheels tracks that goes around, great. If not, you can just use a board that's 1.5 meters long, a toy car, like a Matchbox car, or anything like that, a meter stick. You could also use a tape measure if you don't have a meter stick, and then a timer. If you don't have a timer on your watch, you can use the timer on your stove or your microwave or a computer or your parents' phone or your own phone. So do your best to try and complete that lab. If you don't have those materials, again, totally cool. It's okay if you don't get to do it. But if you do have them, give it a try and map out that acceleration difference. And so the question is, how will velocity and acceleration change over time? And so that's what you're going to be graphing and calculating. So enjoy learning a little bit more about motion and forces of motion, and we will talk more next time on the next chapter.